Okay, we're recording the solutions for test number 4, which is whatever sections 4.3 and 4.4. So starting with number 1, you have the natural log of x plus 3 minus the natural log of 5 over x minus 2, and you're taking a limit of that as x approaches 2. This wasn't really a major issue. The good thing is that I think you guys recognize that this is just a derivative, right? And we even had a quick discussion about that before our test on Tuesday. So that just means that that's just f prime of 2 if f prime of x, if f of x equals natural log of x plus 3. So remember, there is a formula, right, that states that f of x minus f of a over x minus a, the limit as x approaches a. That's f prime of x. Sorry, f prime of a. So our a here is 2, right? And your function is that, natural log of x plus 3. Sorry, it looks really messy off to the right here. So just take the derivative of f prime of x, which is 1 over x plus 3, and then plug in 2. And you're home free. So the answer is just 1/5. I think there may be 2 or 3 people that might miss this one. So take good notes on this. I can't really prevent you from taking pictures. I prefer you guys don't take a picture. I mean, I can't hold you from that, but if you can just write this down, that actually it's probably better if you write stuff out anyway, because it's kinesthetic. So as you write things out, it hopefully sinks in better. So I trust that you guys won't take a picture of this because I really don't want any images out of the circulating. But yeah, please copy this down if you missed it. Again, that just represents a derivative. That's all it is. And yeah, just evaluate it at 2. And the function is natural log of x plus 3. So, okay. I'll go and clear the drawings. And anything you need me to re-explain, please let me know. I'm more than happy to re-explain stuff. And by the way, the answer choices, I do mix them up. So don't worry that, oh, wait, I picked C and the answer is B here. I actually have Schoology shuffle the answer choices, mainly for academic honesty reasons. But the answer is 1/5 though. So that's the story of that question. By the way, for partial credit, I did look at your work. If you missed a problem, but like made a careless mistake, or there's one little step that you kind of forgot about, like maybe a chain rule or something like that, I probably give you like 4 out of 5 or 3 out of 5, depending on the kind of error you made. If you really were kind of lost with the problem, but you put something down, then I give you 1 out of 5, or maybe 2 out of 5. If you have nothing, then I can't give you anything, right? So, the next one here. There was actually a 5 or 6 of you that missed this problem. And I was a little perplexed. So you can't forget old stuff, just so you know. This class, and we've actually interwoven, and I know we're in the pandemic, we're in remote learning, and I know it's not as easy as it is at being in person. I get that. But given the fact that maybe as our seniors and a few months away from graduating, going off to college, and hopefully you could actually go to college, right, and be around people. I feel bad for the current college freshmen that didn't have the typical senior year experience in the spring and didn't have the typical freshman. I think that group probably had the roughest. If anything, if you're a current senior, usually, you probably want to be home anyway because you're doing so much work the second semester of junior year and the first semester senior year. The point I'm trying to make is that if you're a senior, you are a few months away from going off to college. And so you are going to be exposed to a lot of classes done this way. So you do want to make sure that you're staying heavily engaged in the material. Yes, we did cover linear motion in the previous unit, but it doesn't mean that you can forget about it. And I have interwoven. It's not like, okay, I cover something that I haven't. If I don't interweave anything, that's my fault as a teacher. But I feel I have done that, like in the notes and in the homework assignment. So to make sure you're really following that stuff carefully and you're taking the homework seriously and understanding your notes carefully. And of course, see me if you're stuck. That's just something made to keep in mind for next semester when we continue this remote learning for a 4-week period in January. So you're asked to find when the particle's at rest. You're at rest when your velocity is 0. when you're not moving, right? If like I'm not moving right now, I'm at rest. But if I'm moving, I mean, there might be a time where my position is 0. Depends what you define as the 0 position, like your starting place, right? Like I could get up and move forward, right? Great. Now I'm back at the 0 position, but I was still moving, like went back to the 0 position. So some of you guys just set this equal to 0, and that's actually incorrect. You don't set S of t equal to 0 for particle at rest. You never ever do that. Instead, what you want to do is find the velocity. Remember, it's a calculus class, right? You got to do some calculus work. So v of t is s prime of t. Take the derivative. That's an easy one. That's just you have a formula for this. You have a formula sheet, which I made for you guys. So that's the other thing too, is that sometimes it's hard to have like all the materials, but I have provide all the materials. So you have all the materials available too, and I even print them too. And the derivative of that one's 2t. And you have to set this equal to 0. Then you kind of just move things around, like 2t equals 1 over 1 plus t squared. And you can cross multiply 2t plus 2t cubed equals 1. Get everything on one side. And then you can use Desmos to graph it. That I'm not worried about. That actually, some of you guys picked A because that is the that's the answer you would get if you did set the position equal to 0. So A was actually done as a trap answer choice, just so you know. The College Board likes doing this. And these questions, just so you know, I do get it from the College Board site, but it's actually a very special privilege I have as an AP teacher. I have access to these questions that are not available to the public, and I actually have to go through a bunch of like layers to get to this question bank. So that's where I get these questions from. I do tweak them though, but most of the structure of these questions I get from there. So these are AP style questions too, and this is a standard that you guys have to be able to meet by the end of this course. So yeah, you want to make sure you're comfortable with these types of questions. And I'll be giving you more practice to this kind of stuff next semester. Anyway, when you solve this correctly, you get D. So I trust you guys to use Desmos and find the x-intercept, so I don't need to do that. We'll keep moving. This one was okay. Some of you guys had some trouble with this one. So, and I actually did kind of a practice question like this right for our test on Tuesday. So you have a line tangent to this equation, right? And you want to find what k equals. K is going to be the x coordinate on the point of tangency. So e to the x, looks like this. And look, given that all these are positive values, I guess your tangent line will kind of look like this. I just got to figure out what k is, right? And you're told the y-intercept is 1/2. So that's the point you have on the tangent line itself. So what's the equation of a line? We know this. And we know the point of tangency. So you do y minus e to the k equals mx minus k. But we need to figure out what m is. How do I figure out what m is? Well, m, remember the slope is just a derivative, right? So if I take the derivative, you just get that. And if I plug in x equals k into my derivative is going to be e to the k. That's going to be your m value. So e to the k, x minus k. Now it's a little confusing, but here's the deal. You're trying to solve for k, right? You know another point on the line, 0, 1/2. Plug 1/2 for y, and there you're home free. And 0 for x, of course. And what you could do is you could actually let this side be y1, let this side be y2. It's 0 to touch. So we got to start doing some algebra. At that point, it's like, I wouldn't do that. I'm not doing any algebra to solve this problem. I would just, that's why I even told you to use your calculator. At that point, just graph 1/2 minus e to the x. Use x instead of k in the calculator, right? Or in Desmos. And then e to the x times negative k. Or sorry, e to the x times negative x, right? And then you should get 0.768 if you do it correctly. So that's number 3. Some of you guys got to this point, but then again, did some weird algebra. So I gave you 3 out of 5 for that. But really just, now if you did graph this, but maybe your graph was off a little bit and you didn't quite get that answer, but you kind of showed me that you did graph it, then I gave you 4 out of 5. But I think for the most part, this was a fine problem for many of you. Question in the chat. Yes, you're so at the very end, you're looking at the intersection of y2 and y1. Let me undo. Yes, you're looking at where they touch, and you're looking for the x-coordinate where they touch. 100%, absolutely. Some people move the e to the k on the left side to the right side. That's fine too. Then you have negative k times e to the k plus e to the k, because you move that negative e to the k from left to right. Then you can do y1, y2 again. And y equals 1/2 is just a horizontal line. And that's just some sort of weird kind of curve that touches at some place, 0.768 for x. Number 4. This was okay too. We had a problem kind of like this in a previous test, and we did a review of this right before our exam. So I felt this was okay. Here's the issue I'm having though. And this is the part that I don't think is very forgivable. You got this, right? You need to do a derivative of that, 1 over x squared plus 1. Awesome. You got that. You need to do a derivative of that, 5x4 plus 3x squared. Awesome. You need to plug a in for the g derivative. Great. So you have 5a4 plus 3a squared. Fantastic. You know there's going to equal each other because they're parallel. Fantastic. You're doing great so far. You need to plug in 2. Great. Fantastic. I know I'm repeating myself. Here's the problem. Can someone tell me what mistake I just made? What mistake did I just make? You can put it in chat, or you could speak in your microphone. It's a pretty big error from the last unit. What's inside the natural log, guys?
Wait, what was it? Can you repeat the question?
What mistake did I make? So I know some of you guys got it right, so someone could tell me.
You have to do the derivative of like x squared plus 1.
Thank you, Emily. Appreciate it. Yep. I forgot the chain rule. I would say probably, I can't remember exactly, but 5 or 6 of you guys forgot the chain rule. Derivative of x squared is 2x. You got to do the chain rule. Again, it's not like, okay, we covered chain rule in November and then I completely neglected. Chain rule has been interwoven every class we've had in December. Every set of notes, I've interwoven this. So it's actually going to be, when you plug 2 in, you're going to get 4/5 up top. Now you actually solved it, and you should get 0.447. If you didn't do that, then you got 0.246. That was also done as a trap. Remember, the company who writes the AP exam is a College Board. The College Board is also the same thing that writes the SAT. I know many of you didn't do the SAT or didn't get a chance to. Some of you probably prepped for it and didn't take it. Some of you probably did the PSAT prior to the pandemic. So you're kind of familiar, you should be somewhat familiar, I suppose, that they do put trap answer choices. Like they anticipate kind of they're going to make, and they will put that choice there to make you think you got it right. It's kind of cruel they do that, but that's the reality. That's how they write these exams. And so, yeah, it's not 0.246. It's actually 0.447. At that point, I trust you guys can solve for A. Just let y1 equal 4/5. Let y2 equal 5x to the 4 plus 3x squared and see where they touch. Or you can move the 4/5 over from left to right and find the x-intercept, because the other side would be 0. You can do that too. But yeah, that was the error some of you guys made. So you forgot your chain rule. You can't forget that. Okay, next one here was okay. I say about half of you guys got this. This is a little hard to get partial credit, so I tried my best to give you some partial credit. If you think my grading is a little harsh, just talk to me, and because I'm gonna put you guys in breakout sessions afterwards, so you can do some extra work, or if you want to prepare for your other, if you have another exam later today, and you want to use the time for that, that's totally fine. Or if you have homework to make up, or I don't know, or just want to hang out, that's fine too. But I am going to put you guys in breakout sessions just a little bit. Anyway, this right here. So you have f of x, and we know that 4,6 is a point on f. So I can make a little table here, right? So on the inverse, which actually I'm calling g, is 6, 4. So f prime of 4 equals 1 over g prime of 6, right? That's the rule we have. F prime of 4 you actually could find. That's the slope of the tangent line. I can find that slope so easily. Go from the y-intercept, we go down 3, right 4. So my slope is negative 3/4. But because g prime 6 is the reciprocal of it, therefore g prime 6 is negative 4/3. And you just pick the right answer and you're done. That's all you gotta do. Some of you guys didn't flip, but knew the switch to x course. Some of you guys flipped, but didn't switch the input. If your explanation kind of made some, or you kind of showed some work here, then I'd probably give you 3 out of 5. But if you're just your work didn't make any sense, or I can't tell what you're thinking, then I'd probably give you 1 out of 5. But the answer is g prime 6 equals negative 4/3. So you know, it's similar to what we've done. Okay, now I let a huge sigh. We're going to the free response. I will admit that this does look a little wonky. We have done stuff like this, though. This is not unusual. We did do stuff like this back on test 3 here. Or maybe it was a quiz. Hold on. I don't think it was test 3. We had it in the homework and the notes. Yeah, my bad. It was actually in the quiz. Yeah, we've had stuff like this. It's not unusual. Here's the part that was a little disheartening. But let me see some questions in the chat. Oh, no, thank you, Bill. No problem. And we'll just get on what you can. Yeah, here's the part that I think was a little disheartening. So here you're told g equals this, right? And you're asked to find g prime of -1. So it means find the derivative of g. Then plug in x equals -1. I would say a majority of you guys crashed and burned, just putting it quite bluntly on this question. I'm going to do it a wrong way. I want someone to tell me what I'm doing wrong. I'm going to deliberately do this wrong. Here's what I saw. Okay, I've actually done several things wrong here. Can someone tell me one thing I did wrong?
You didn't do chain rule?
I didn't do chain rule. Yeah, so if I take derivative f prime of x squared, I definitely got to do a chain rule. So I definitely have to do this. I got to do times 2x. But an even more egregious error.
You can't just take the derivative of the top and the bottom.
Thank you.
You need the
What rule do you have to use here?
Quotient.
Thank you. Quotient rule we did, I think, our 3rd unit. And that was the part I found disheartening, is that you guys can't forget these rules. You know, just so you know, in calculus, like, everything's interwoven. Everything carries from the previous unit. And I do my best to interweave it. You really, and I know it's hard to stay engaged with the material when it's remote learning, but we are going to be stuck in remote learning. Just so you know, that's reality next semester anyway. So I mean, I'll be on campus from time to time if you happen to be on campus, if we could even reopen our campus. But yeah, you guys got to do your quotient rule. I'm going to show you right now. You could do that too. Someone asked, could use the power rule with negative exponent. You could do this if you so desire. You could do f of x squared times e to negative x. That's fine. Then you got to do the product rule. I had some people that did that. That was fine. But then they didn't do the product rule. So that's another rule too that you guys forgot. So yeah, you got to make sure you remember all the rules here. So if I do remember, if you have f over g, f prime times g, oops, sorry, but minus. And by the way, it's on your cheat sheet. I mean, heck, I'll even just show you right now. It's right here. Again, you don't have to like thumb through your notes. Like some people like to say, well, I got thumb. No, total BS. You don't have to thumb through your notes at all. It's right here, right smack dab. F over g prime, boom, there you go. Use it. So over g squared. Now let's actually do the derivatives correctly. The numerator is f of x squared. That's what this is. It's just that over there. So you got to do the chain rule, of course. So it's f prime of x squared, but then times with the inside times 2x, and then g, of course, is e to the x minus your f, just f of x squared straight up. That's the top function, right? The bottom function is derivative e to the x is e to the x. So that's cool. And the bottom is e to the 2x. So you got to square it. If you did all of that and then made a mistake, I give you 3 out of 5. But then you got to plug in -1 correctly and get the right answer. If you plug in -1 correctly and get the right answer, let me delete all that and erase this chunk here. Okay. So yeah, f prime, and I'm plugging -1 in. So if you square -1, that's 1 times -2 times e to -1 minus f of 1 times e to -1 over e to -2. F prime of 1, just look at the table, is 4/3. So 4/3 times -2. Now, some of you guys did do the quotient rule correctly, but then you forgot this part. I took off 2 points, you forgot that part, because that's still pretty egregious if you forget chain rule. And then, of course, that's times e to negative. Well, actually, I'll just make it 1 over e. And f of 1, of course, is 2/3 times 1 over e. And the bottom is 1 over e squared. You could probably factor out 1 over e from the top. So you have -8/3 minus 2/3. And the bottom is 1 over e squared, which now you can flip. E squared times 1 over e times -10/3. Those cancel, you get -10 e over 3. So that's how that one's done. There were about 5 or 6 of you that actually nailed this one, that did it, flawlessly. There's some that got to, but may have made a mistake within the algebra. So I probably give you 4 out of 5. It will be kind of hard to tell how I divvied up the points, because I just gave you the whole part, the whole thing here was out of 15 points, all number 6. So yeah, maybe I might need to rethink how I craft this next time as an online exam. Maybe I'll just do is fill in the blanks in 3 parts. I'm sure there's a way I could, or just break it up as just 3 separate problems. I don't know, and just carry on the information to the other. Maybe I'll do that. I don't know, because it is kind of hard to tell. Like, okay, if you got like 12 out of 15, where did I lose my points? I think you'll know when you see the answers. So I'm showing you the answers now. So hopefully you're recording this, or I'm starting recording. I mean, your thought is down somewhere, and then you look at your work. You'll hopefully know like where you missed your points. So yeah, that's part 1. Any questions before I do part 2 or part 3? Nope. Okay. Let me clear my screen. Let's talk about number 2, or part 2. Part two, again, you're trying to find h prime of 1. So h prime of x is simply going to be the derivative of what you see on the other side, right? But you got to do a chain rule. Maybe you guys forgot the chain rule. You still got to do a chain rule. The chain rule doesn't like vanish. It's still there. So it's -2. And then derivative the inverse. Before you get too carried away with it, let's plug in 1 for x. I plug in x equals 1 for x. Okay, so you want to find the derivative inverse at -2. Well, we know if we do a little table here, if you have -2 as an x coordinate on the inverse, it's -2 as a y coordinate on the regular or the original. Well, on the original, when y is -2, x is -1. So -1, -2 is on the original, -2, -1 is on the inverse. But f prime of -1 equals 1 over the derivative of the inverse, evaluated at -2. Or you could write it like this, the way I wrote it earlier. Like that. So f prime -1, I could get from the table as well. F prime -1, 6/5. So I just got to flip that over, which of course will be 5/6. And then 5/6 times -2. So if you do 5/6 times -2, you should get the right answer. So the final answer is -5/3. But you can't mess up the chain rule. You got to remember that. And the other thing too is, you got to know how to do inverses. This was, I think, a little more challenging than the other inverse one, because you had to kind of work backwards. You had to, use the y coordinate, and then get the x coordinate goes to that from the table. So maybe that threw into a loop, perhaps. I don't know. But yeah, you're just doing the derivative. The outside function is an inverse, right? Chain rule times the inside, and then the derivative of the outside against an inverse. So just do the rules that we talked about for inverses. That's that for that one. Okay. Any questions before I wrap up part 3? Nope. Okay. Part 3. Someone's asked why I multiply by -2. Chain rule. The chain rule. That's why. Derivative of -2x is -2, because that's your inside. So, because here's the thing: what if h of x equal f of 2x? You still do the same thing. H prime of x equals f prime of 2x, but then time derivative of 2x, which is of course 2. So, still got to do the same thing. All right, last bit. Okay, this I also found just as disheartening as part 1. So here's a mistake. So again, you find derivative of k, evaluating at -1. Great. So some of you guys did this. Okay. And then you plug 1 in. Sorry, -1 in, and you worked it out. 2 big errors. What are the 2 big errors that were made here?
Forgot chain rule.
And
Product rule.
thank you. Yep. Yeah, you guys can't forget this stuff, because we're going to be getting to really, really sophisticated, complex stuff in next month. So this stuff has to be, you got to be able to recognize the product rule. Just the reality. My hope is that because we're only doing 2 classes and we're going to see each other every day, and I'll be available on Wednesdays as well, for during the AP study group session. It's not just for my B and D periods, it's for you guys too. You guys can totally be part of that. Yeah, that you'll be more heavily engaged with stuff because you got to remember all the stuff here. So this is actually wrong. So if you forgot it, please, with emphasis, cross it out and tell yourself that you did something very, very wrong. You can't forget product and chain rule. Maybe I'm starting to think now, like maybe you guys forgot it because you didn't see an actual expression here, but it is a function. It's f of x is a function. I even tell you f is being multiplied. I even wrote that out explicitly. So I'm not sure what else I could do, but this is an AP style question, so you have to get used to this kind of style here. So can't forget product rule or chain rule. So let me do it correctly now, then I'll wrap things up. Anyway, if I do it correctly, k prime of x will be f prime of x, and then times the inverse sine of blah, 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 right? Plus f of x. And then you got to do derivative inverse sine, which is 1 over the square root. You have the notes there on that, the formulas. X over 2 squared. But then you got to do the chain rule. 1/2. The derivative of the inside. So you can't forget that. You do that, at least you get 3 out of 5. If you didn't do that and you did some really weird, like if you did the bad stuff, I gave you 1 out of 5. I wasn't very forgiving in that regard. Now plug in -1. Inverse sine of -1/2, which actually use your calculator for if you want. I don't care. But you should know from the unit circle anyway, because this could be a non-calc on an AP exam. F of -1 times 1 over the square root of 1 minus 1/4. If you plug a -1 in, you have -1/2 base square, you get 1/4. And you got times 1/2 over here as well. If you keep moving, let me erase the stuff up top now, because I need that space. If we keep moving, f prime -1 is easy. That's 6/5. Hopefully you guys remember your trig. Inverse sine -1/2 is actually -π/6. Remember, it's always in radians. One of you actually did in degrees, so I took up a point for that. Or some of you guys didn't do, or some of you guys did some weird stuff too. Some of you guys actually didn't do an inverse. You actually did a sine, or you put π/6 aside. It was weird. But it's just inverse sine, so it's -π/6. F of -1 is -2. Let me put all these in parentheses because there's a lot going on here. 1 over the square root of 3/4 times 1/2. Excuse me. So you get -π/5. And the 2's cancel. These cancel here. So you get -1 over √3/2. You can square up both top and bottom separately. So final answer is -π/5 minus 2 over √3. You can leave your answer like that. If you left it kind of like up above as well, that's fine, I suppose. I think I'd still give you full credit if you did that. But yeah, that's that one. Okay, so I will consider curving this exam as long as averages for B and D period are similar to this class. I don't remember what this class's average was, but if you guys and I hope you guys don't share this with any people. Just if someone says, hey, what was on the test? Like, dude, you'll find out. Just say that. Because if you do share and their averages are higher, I'm less likely to give a curve. And I do feel your abilities are just around not stronger than B and D periods. So it's not like, okay, this is the weak period. No, all you guys are equally strong. I've never, trust me, I would notice that from day one if I knew the abilities were not comparable, or from test one actually. I've known that more quickly. So I know you guys are brilliant, so just don't share this, please, with anybody. But I will consider curving it if that will help some people. Some grades did drop from an A to an A minus or A minus to B plus after this test. But if you do the corrections, you should be able to get back to that other grade. Grades may not matter anyway. Some of you guys are already in the college, you know, and like, you know, as long as you don't get C's, and I don't think anyone's really in the danger of getting that. So, you know, but if you do want to finish with a better grade, you know, you have that opportunity. So use this opportunity for the next 30 minutes. I'll put you guys in a breakout session just a minute or two from now. Really quickly, let me